Hi everyone, it's me, Carolyn, and today's lecture or today's little video here is going to cover sections 3.4 and 3.5 together. They do kind of go hand in hand, so that's why I like to do them together. In these sections, we look at the position of a data point and how we can kind of compare where you are in place of the data, like rankings and things like that. The measurements we use are a z-score, and we also will look at percentiles. And then we'll turn over and we will look at what we consider another type of graph called a box plot. And that is a nice way of displaying data so we can kind of see the shape. We can also see if there are any outliers. I will also show us how to do this in StatCrunch. You can do a box plot in Excel. I'm not real happy with theirs, but you can play around with it and maybe get yours to look better than I could get mine to look. But they're easy enough to do by hand. The calculations aren't so bad. You can use Excel or other software to help you find those calculations in doing so. But let's turn it over to our guided notes and go from there. And here we are. Again, we are looking for position. And the first measure of position is something we call a z-score. I like to sometimes think of it as a standardized score because you're kind of taking the data and standardizing it so we can compare one situation to another situation even. So, I mean, they can be completely two irrelevant, non-connected situations and we can compare data points. And we can also use it to compare data points within each other to kind of know some things. But the z-score will be something we will see later on as well. And again, I like to call it a standardized score, but it basically tells us how many standard deviations we are away from the mean. You can remember from earlier lectures that we did have special information. We knew that 68% of our data were within one standard deviation from that mean. So if you have a z-score that's less than 1, you're going to be in that first 68%. If you have a standard deviation, z-score, a z-score between 1 and 2, you're going to be within that, not past the 68%, but before that 95%. So you can kind of get a feeling as to where on your curve, provided it's normal, bell shaped, so that 68, 95, 99.7 rule works, but you can kind of tell where you are located. All right, so we're going to use this to help us kind of compare two test scores of a student. So we have a student who does take 2 exams. Okay, they scored an 88 on both of them. So they scored an 88 on our math test, and my next sentence down here says they scored an 88 on their econ test. Now the math test has a mean of 72 and a standard deviation of 7. The economics test has a mean of 80 and a standard deviation of 3. And we kind of want to know which one did they score better on as compared to their peers. I mean, it's hard to tell just looking at some of it. They got an 88. So what we can do is we can look at the z-score of both of those and use that to help us determine. So I'm going to calculate the z-score. Sometimes we will just use the letter z for both our math and our economics. Okay, now I didn't really go through the formula, but what it is we're going to take our x, or our data value, and we're going to subtract off this, in case of a population, this mu, which represents our mean, and then we're going to divide it by that standard deviation. So that's our lowercase sigma, which stood for the standard deviation. If we have a sample, we have the similar symbols that represented our mean and our standard deviation. So we basically take the data value minus the mean and divide by the standard deviation. So I'm going to do that in both cases. So our data value in both of these is that 88. That's the score that we got. We're going to subtract off our mean. So in the math case, it's a 72. And then divide that by our standard deviation of 7. So I'm going to use my calculator to do that for me. So take my 88 minus my 72, divide that by my 7, and I get 2.2857, and there are a ton more digits, but I'm just going to kind of stop there. In the economics test, we're going to take that 88, subtract off our mean, which was an 80, and then divide it by our standard deviation, which is 3. Again, using my calculator to do the work for me. I get that this is a 2.66 and so on. So it does a repeating 6. So now if you think about where we're sitting, we are both above the mean because we do have a positive. So this is telling me I am a positive 2.2 standard deviations from the mean. Here I'm a positive 2.6 standard deviations above the mean. So if you think about it, the more away you are from the mean, the better you are going to be doing compared to your others. So for this example, this student did better as compared to other students on the econ test. Okay. Later on in our studies, we will actually be able to turn these numbers into our next topic, which is a percentile. So based on if it is a normal curve or that bell shape, we will know that if they are a 2.66 z-score, that they are in the whatever percentile. So we need to talk about what percentiles are. So this percentile and the z-score will come back later on down the road. All right, a percentile, and you may have heard this term before, someone saying that a student scored in the 75th percentile, or your child's height is in the 85th percentile, or your child's head circumference is in the 12th percentile. And you're like, what in the world does that mean? Well, what that word percentile means is it's telling you what percent of the population is at or below where you are. So when you have been told that you scored a 75th percent, you're in that 75th percentile, that means 75% are at or below you. Okay, which means 25% are above you. If you've scored in the 50th percentile, you're smack dab in the middle. There's 50% below you and 50% above you. So you can kind of know, but that percent tells you what is below you. And I should probably do this backwards, but it's a number that is below you. All right. You can calculate the percentile by counting how many people are at or below you. So I'm going to do an example here. We don't do this very often because if we have a lot of data to count how many are here or below, can take a while, but you could use Excel, order your data from smallest to largest, find out where your point is, you know, and then if you look off to the side, it will tell you where you are at. Okay, so we are going to count here. We have looking here some data, and I did order it for us, so it's a little easier for to do. And we want to know the percentile for the value 12. You'll notice we do have 12 listed twice, so we need to count how many are at or below that 12. So 1, 2, 3, 4, 5, 6, 7 of us are at or below that 12. So we were going to find our percentile by taking the 7 out of our total. So we have 8, 9, 10, 11. So 7 out of 11. Turning that into a decimal is 6363 and repeats and repeats and repeats. Turning that into a percentage, so we are basically 63.6%. So we are in the 64th-ish percentile. So if you round it to the nearest whole percent, we are in that 64th percentile. We can also find percentiles using a tool we've seen before in chapter 2, namely our ogive. Okay. And I did spell this wrong. Sorry about that. I changed it. Must have went with an old version. But this is an ogive. Oh, I prompted it here, but title of my graph is misspelled. Sorry about that. But this is going to be some test scores. So let's say we had some students take a test and we created the ogive, which remember accumulates as we go. And so we can use this to kind of determine, and I put the relative frequencies here, not the frequencies, but the relative frequencies. So if you think about how we did it, we were continuously adding on as we went up the scale. So if we want to find the value that represents the 60th percentile, that would mean we want to find that 60% over here. And if I go over here, we get this 80. So the 80 is when we had 60% or more, less. At that point, we had 60% of our people. So 60% of our data is at that 80 or lower. If we want to find the 90th percentile, we would go to our 90 up here. Notice I did jump from 0.8, so I'm going to have to kind of eyeball it between the middle. And that would give me a 95. So we'd have a 9 score of 95. We have to be a little bit careful if we are in the middle of classes, because then we could be a little bit off on our lines, because remember we connected the one to the next with a straight line. So trying to find this value in between, we're going to be eyeballing it a little bit. And that's okay because we're getting estimates. And we want to know what percentile does at 65, the score of 65. So our scores are here. So here it tells me it's a 0.3, which means by the time I reached 65, 30%, 0.3, 30% were below us. So we are in that 30th percentile. Okay. So you can kind of pull some of that information off of those relative frequency ogives. Okay, we do have some next topic is kind of looking at quartiles. And I may be going a little fast here, so I'm going to kind of try to talk a little slower. I feel like I'm going fast anyway. But the first quartile is we will denote with a Q standing for quartiles. We'll put the 1 here, Q2 and Q3. We do have 3 quartiles. And what these numbers do is it kind of divides our data into pieces. And we'll see an example as we get towards the end of this lecture. But the first quartile, the way we find it, it is the median of the lower half of our data. Our second quartile is the median of the entire data. And the third quartile is the median of the upper half of the data. Another piece of information that we'll be using in a bit is something we call the IQR, or the inner quartile range. And to find that, we would be subtracting that Q3 minus the Q1. Okay. My question would be are these values resistant? All right, now resistant means that large values and real small values won't affect it much. And the answer to this question is yes, it is resistant because it's based on the median. And if you remember, medians are resistant as well. So they're not going to move a whole lot if we throw a really large number at one end or a really small number at another end. They're going to stay relatively the same. They might slide up a little bit or slide down a little bit, but they'll stay pretty close to where the single values are. If these values were based on a mean, an average, then they would not have been resistant. But they are based on a median. Okay, so I'm going to turn my page here. The reason we like that interquartile range is we can use it to kind of identify an outlier. I mean, sometimes we'll have a large value or a small value, and we'll have to say, okay, is that big enough or big? How do I say this? So it's a little bit bigger than our data, but it's like, is it far enough away from our data to be considered an outlier, or is it just a little bit bigger than our data and it's not really an outlier, it's just kind of a little larger or a little smaller? So we need to kind of know how far away from our data do we need to be in order to be considered an outlier. And the way we do that is by using that interquartile range. Again, something that is resistant from those outliers. So we will use it as a kind of a basis. And what we can do is create some boundaries or fences, so to speak, that this is how far you can be away and not be considered. If you're bigger or smaller than these two fences, you are considered an outlier. That's what this is kind of set. So we're going to be setting up some boundaries using that interquartile range. The upper fence, so that upper limit, so to speak, or that upper boundary for outliers, we will find by taking our Q3, again, a resistant value, and adding 1.5 times that interquartile range. This is multiplication going on here. 1.5 is a value that they have used, and they've calculated it and studied it, and it just turned out to be a nice one that works. So 1.5 is the number we will always be using. We use Q3 because that's the upper part, and we're going to go a little bit more above it. Our lower fence, or our lower boundary, kind of like the boundary for this extra small piece, is taking Q1, which is, again, a resistant value on the bottom end, and subtracting off, so going a little bit further down, 1.5 times that interquartile range. So now that we've got all these little pieces, let's kind of figure it out. All right, so here's the data set. We have, and I did put them in order to kind of help us out. And we're going to kind of find all those pieces that we talked about, the quartiles, and to see if we have any outliers. Okay, so first thing I'm going to do is I'm going to just rewrite, well, actually, I'll just use it up here. So we're going to find our Q1, our Q2, and our Q3. Okay, I start with finding Q2 first because this is the median of the entire data. Okay, so the median, so the middle of our data. All right, so since it's ordered, I can kind of back in and find my middle. So my middle is kind of between those two. Okay, so I'm going to kind of put a little line. That was where my median would be. Now remember, if we don't have a middle value, we will add the 2 around it and divide by 2. So I'm going to take that 58 plus my 62 and divide by 2, and I get 60. And you'll notice 60 is 2 units above 58 and 2 units below 62. Okay, I also put that line there so we can now see the bottom half of our data and the upper half of our data. Okay, before I go too far and actually find Q1 and Q3, I kind of want to talk about if you have, let's say, 7 values. So 1, 2, 3, 4, 5, 6, 7. And you are trying to find that Q2. So 1, 2, 3. This would have been your. Now, when we go to talk about our upper half and our lower half of our data, this value is not going to be considered at all. So this would be your lower half, because they're smaller. This would be your upper half of your data. Okay, when we don't have a true middle, that median isn't going to be in either of those sets. So this is our lower half, and this is the upper half of the data. Okay, and you can use Excel to help you, or StatCrunch for that matter. I like using Excel for this because Excel, you can quickly order your data. You can quickly find your median. Okay, so you could use the median function, and then you could locate it on your pictures, and then you can find the medians of your upper and lower halves by adjusting the values. So you could just highlight these guys and calculate the median again. You could highlight these guys and calculate the median again. I believe there's also functions out there for the Q1 and the Q3. I haven't used that enough to feel comfortable showing you. So this is, again, something I usually just do by hand, just because most of the time in this class, we will have small sets of data. So, all right, we're going to find Q1. That is the median, so middle of the lower half. So I'm looking at this thing, and I'm finding my middle. So it is right here. So my 45. I am going to find the middle, the median, middle of the upper half. So the middle of the upper half here is 65. Okay. What these values have just done for us, so I kind of want you to look at the picture. We have roughly 25% of our data here, 25% of our data here, 25% of our data here, and 25% of our data there. So it kind of just divides up our data into 4 equal areas where there's 25% in each of those regions. Kind of nice. Now, we're going to see if any of these values are outliers. Now, outliers are extremely large or extremely small values compared to the rest of our data. Now, if I look at my data, well, these both look kind of small compared to a bunch of these others. If I look here, well, 83 is a little bit larger than the 77, but is it large enough to be considered an outlier? Just like these guys, are they small enough to be considered outliers? And that's where these fences will come into play. And in order to calculate those fences, we need that inner quartile range. Our inner quartile range, again, is that Q3 minus the Q1. So I'm going to take 65 and I'm going to subtract 45 and I get 20. So there is our inner quartile range. Okay, now we're going to find our upper fence and our lower fence, or you could find the lower fence and then the upper fence. I don't know why I do upper and then lower. I just do. And this is equal to our upper fence. We're going to start with Q3. So this guy up here, that Q3, and we're going to go up a little bit. So we're going to go up 1.5 times our IQR. Okay, so I'm going to put the numbers in there. So it's our 65 plus our 1.5 times 20. Remembering we do multiplication before we do addition, order of operations, multiply before we add. So 65 plus, I believe, 30, which will be 95. You can do the lower fence as well. So we're going to take Q1, the bottom end, the middle of the bottom, and we're going to go a little bit further down. So 1.5 times that IQR. So in this case, 45 minus 1.5 times 20. 45 minus 30, which is 15. Okay, so now to be considered an outlier, you have to be larger than 95 or smaller than 15. Okay, we have no data values above the 95, so this 83 is not considered an outlier. Okay, Below 15, we did have one, just the 3. 17 wasn't low enough. So the 17 is not considered an outlier, even though it is considerably lower than some of the other spots, but it's not low enough. So 3 is our only outlier. It is possible to have no outliers. Just so you know, it is possible to have 2 on one end, 3 on another. It just can happen. A lot of times it depends on how many data values you have and how closely compact that kind of the middles are in relationship to each other. Another thing to kind of note when you are working through things, it is possible that your lower fence goes negative. Okay, if you were subtracting off a bigger number than your Q1, it is possible. If this had been a 50, we would have been at a -5. And that's kind of going to tell you, hey, I'm not going to have bottom lower, I'm not going to have possibly a lower outlier. Okay. Our last thing that we're going to talk about is going to use all this information and draw a picture, because it was nice. I mean, when we had this, we can kind of see, because I have all my data sitting there, the 25% of each pieces. But if you put it on a scale, we can start to see things being skewed one way or another, left or right. So we're going to create what we call a box plot. All right, and a box plot is another way to graph our data. It's going to kind of lose the original data, so we're going to be kind of using those pieces of information that we had, and we're going to be using a couple more. So we're going to be using what we call the 5-number summary to create this. Some textbooks, not ours right now, but I have seen other textbooks will also put the fence, that upper fence and that lower fence, into the graph. I will do that in this picture, in this when I create by hand, but we'll see when we go to StatCrunch that it does not put the fences in there, but it will use fences if you want to kind of identify outliers. And I do like that feature, being able to identify that, hey, this guy's an outlier. All right. So the 5-number summary is our smallest value, our Q1, which is the middle of the bottom half, Q2, the middle of all of our data, and Q3, the middle of our upper half, and then your largest value. So you need all of those pieces. Sometimes you will need a little bit more, especially if we have outliers. And we'll talk about that as I draw this. So the first thing I'm going to do is create my scale. Okay, now my data went from a 3 up until an 83. I think what I'll probably do is just go up by 5s or maybe by 10s. I don't know what these numbers stood for, so I can make some sort of title up. And let's just say that these were scores on an exam. Okay, and so we could have possibly had a 0, and I'm going to go by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90, and I could go all the way up to 100 because it's possible someone had gotten 100% on that exam. So this would be our scores, or your exam scores, whatever you want to label it. We will not have a vertical axis on this one because there's really nothing that we're going to be measuring up and down. A box plot is just and I like to do mine horizontally. I've seen them done more vertically, and I believe that's the way that Excel does them. But we're going to do it in StatCrunch just to show, and feel free to play with Excel a little bit. And it would probably be under, I don't even want to guess. But anyway, let's get our values here first of all from our data, that I can use them. So we need our smallest value. Well, that was a 3. Q1 was at 45. Q2 was a 60. 3 is a 65, and our largest value was an 83. And again, I'm going to use my fence to also identify outliers. Okay, so first thing I'm going to do is draw my box. And the box is created by these 3 values. So this is going to create the box. Another thing I should tell you before I go too far is some textbooks will not call this a box plot, but they will call it a box and whisker. I will put that back up here. Box and whisker. Kind of like the whiskers of a cat. Okay, and you'll see why it's called a box and whisker. All right, so the box is going to be created by these 3 things. So I'm going to have at 45 is a line going up and down. I'm going to put one at 60, and I'm going to put one at 65. And I'm going to create a box. So there's the box part of the box and whisker, or the box plot. Okay, then what I'm going to do is, for me, I'm going to put in those fences. I'm going to draw the fences in. And if you look at different textbooks, they're going to use different notation for that. One textbook I have seen that uses the fences, they will put that upper fence in, kind of like a square bracket. Okay, notice that that has nothing to do with the actual data. So we did not have a 95 in our data. And we also would put in that 15. Okay, so I'm going to draw them. And like I said, some textbooks do not draw those fences in, but I'm going to put them in there here just to make this graph a little complete. All right, now we're going to do our whiskers, and I'm going to do the upper one first. Since we did not have any outliers, our whisker, we're going to put a dot at 83. So I'm going to kind of eyeball where 83 is. And then we draw a line from our box to that dot. So there's the upper whisker. We're also going to do one for the lower end, but notice, remember that 3 was an outlier. So I don't want to draw a line all the way to 3. What I'm going to do is I'm going to draw a line to the smallest point within the fence. So our smallest value inside that fence would have been our next value up, or a 17, which is about right there. And the way we're going to denote our outlier is with an asterisk. I like the asterisk. I believe StatCrunch uses an X, but we'll see in a moment. Okay. The nice thing about this data is you can kind of see this little tail showing up here and kind of see that it is possibly a little bit skewed to the left. We'll see it a little bit more in detail when we go to StatCrunch. So that's kind of where I'm going to go now. All right, so I'm going to stop sharing this screen. Wake my mouse up. Where are you, mouse? There you are. And we're going to go to StatCrunch. And what I've done already in here is I have put in the data. So there's our 3 through 83 with all the points inside. Okay, and we could go and calculate the mean, the median using, if you remember, we could use it doing our summary statistics. This may also give us our Q1 and Q3. So I'm going to just double check and maybe find that out. So we're going to go into columns because our data is in columns. We need to collect variable 1 so that it knows what information to calculate it on. And I'm going to kind of go through and look, and it does. There's our Q1 and our Q3. You have to remember that Q2 is the true median. So if I did this and calculated it, we would see there's our median, that's 60, our Q1 of 45, and our Q3 of 65. So it does give us all those values right here as well. So if you were drawing it by hand, you could pull those off. Okay, I'm going to close this so it doesn't clutter. But I'm just going to use, we're going to do a graph. So if we go into our graphs, because that's where most of our graphs are, you will see that it does have a box plot. So I'm going to click on this box plot. Again, you need to select the column or that you want to create the box plot on. We are going to, I'm going to leave this one here for now, clicked. It's going to use the fences to identify any outliers so that it will show those outliers for us. We can have some markers in here. I'm not going to do them in this particular one, but I'll do this again and we'll put them in and see what difference it is. Okay. Another thing that you can do is you can draw the boxes horizontally, and I will do that on the second version so you can see the difference between the two. So this is just kind of with the defaults. So I'm not really changing anything. I'm just letting it do the work. And here's my graph. Okay, notice the variable is up this way. Notice that dot here down here, that's our outlier that we have. They don't use a little dot, they use another line to represent that 17. So there's our 17, here's our 83, and there's the Q3, Q1, and so forth. And if you hover over them, the values do kind of pop up there for you. So you can kind of see that. Okay, I'm going to do this one again. So we'll just kind of slide this guy over. And we're going to do this again. We're going to go into graph, and we're going to hit box plot again. This time I'm going to select some of these extra pieces. So first of all, I did select variable 1 because that's where my data is. I am going to go horizontally so it looks more like what mine is. I'm going to put in these markers so that we can see where the mean of our data is and the median. Now the median we already have. That was the middle of our box. Okay. And we could choose other things. So you can feel free to play with this, but I'm just going to give you, again, this is going to go horizontally. So I click the draw horizontally box and I'm putting in these 2 markers. Okay, so now this one's going the way I had kind of drawn it. Notice they don't title anything and they don't label anything. This is more for your information to get stuff from. So if you were doing this for someone, you would want to include labels and titles and things of that nature. Okay, now you have to remember the red line was our median. The green line is our mean. Again, here's our outlier. There's our 17. There is our 83. By putting these 2 lines in here, you can see that the mean has been pulled or skewed to the left a little bit. So you can now see how it is skewed to the left. If this 3 had been a lot smaller, or if our data had been more, if these scores had been a lot more compact at the higher scores, you would have seen it skewed even more. So. All right, but that's how we can use StatCrunch to get those pictures. I still think if there's a small amount of data, doing it by hand is not that difficult. So that's why I don't mind drawing box plots or box and whisker plots by hand. Yeah, when I went to school, they didn't call it a box plot. It was a box and whisker. Also, when I was in school way back when, we didn't talk about outliers and actually finding them. So that 1.5 idea, that Q3 plus and that Q1 minus, that was not around yet. So statistics is one of the newer forms of sciences out there, and it is still evolving. So we are still learning about new things all of the time. So it's kind of cool as things change to kind of see that these things are coming into play. But this kind of concludes chapter 3, which was doing some measurements on data. We started the chapter with mean, median, mode, and talked about the centers. We looked at how things were spread out with the standard deviation and the range. Then we looked at some group data, how to deal with group data, and we're ending it with talking about position. And if you do have any questions, by all means, feel free to email me through Campus, and we'll talk to you in the next video. Have a great day.